Imagine a four-legged creature capable of sprinting at nearly 30 kilometers per hour, faster than an Olympic sprinter, cutting through the air like a robotic cheetah. This is no longer science fiction. It is becoming reality in China with the arrival of the DEEPRobotics LYNX S10. In just the first 6 months of 2026, China accounted for nearly 70% of global quadruped robot sales, while launching a wave of extraordinary wheel-legged hybrid machines. From the super athlete Unitree A2-W to the four-legged truck Unitree B2-W. These robots can do far more than run and climb. They are now capable of performing real-world tasks. So just how intense has this technological race become? And why is it making Silicon Valley and the Pentagon increasingly uneasy? Join Mandarin Tech as we break it all down in today's video. For years, quadruped robots played little more than the role of performers under the spotlight of technology showcases. They flipped, maneuvered, and showed off their abilities simply to prove that a lifeless mass of metal could maintain its balance. But in the end, standing upright was only the starting line. Once they left the laboratory, these machines were thrown into the real world. You can now see them trudging into high-voltage zones, crawling through pitch-black underground cable tunnels, pushing through mud and rubble at rescue sites, and patiently carrying equipment while following humans across fractured, unforgiving terrain. Opening the lineup is the AS2-W, a machine Unitree has positioned somewhere between a robotic dog and a compact all-terrain vehicle. Picture it on a smooth road. 4 7-inch wheels carry it forward with ease. But the moment the path suddenly breaks apart or a boulder blocks the way, its 16 articulated joints immediately fold and react. One wheel at a time is lifted off the ground, allowing the 25-kilogram machine to calmly climb over steps as high as 30 centimeters. Unitree did not build the AS2-W simply as a showpiece. This machine can carry an additional 16 kilograms of supplies, following a team steadily over long distances. When you push deeper into steep mountain terrain, instead of exhausting yourself hauling surveying equipment, the AS2-W can shoulder that burden for you. Its ISS 3.0 system, combined with LiDAR and cameras, acts like a pair of sharp mechanical eyes. The robot reads its surroundings and continuously adjusts its trajectory to stay close behind you. Dusty trails or a sudden mountain downpour are not enough to stop it, thanks to its tightly sealed IP54 rated body. Unitree has even opened the platform to developers, allowing engineers to customize the robot for advanced security and field applications. Quietly and relentlessly, the AS2-W helps preserve human strength on demanding journeys. But in China's rapidly evolving robotics race, the title of super athlete certainly does not end with this machine. But that speed limit is immediately shattered by the LYNX S10 from DEEPRobotics. Shaped like a mechanical lynx, the entire machine weighs less than 20 kilograms. Light enough for one person to carry directly into the field. The moment it starts rolling, the robot gradually lowers its body, pressing its center of gravity closer to the ground. Under ideal conditions, it can reach 8 meters per second, equivalent to nearly 29 kilometers per hour. In the blink of an eye, it shoots out of frame with the pace of a remote-controlled vehicle, yet moves with the fluid reflexes of a living creature. Its compact size becomes a major advantage. The S10 can slip through cramped corridors and narrow gaps between broken concrete where larger robots would have no choice but to stop. When an obstacle appears, its control algorithm instantly coordinates the leg joints, lifting the body over barriers around 150 centimeters high, before landing smoothly and returning to full speed. An omnidirectional sensing system mounted on its back continuously scans the surroundings, builds maps, and navigates around obstacles without requiring constant human intervention. Protected by an IP66 rated enclosure, this mechanical lynx can continue operating through heavy rain and dense dust, while tolerating temperatures ranging from -20 to 55 degrees Celsius. More importantly, the LYNX S10 carries the instincts of a scout: compact, lightning fast, and capable of slipping deep into blind spots beyond human reach. Yet even spectacular speed becomes meaningless when the path ahead turns into deep mud, loose rubble, and a disaster site threatening to collapse at any moment. And somewhere in that darkness, another machine is waiting to be awakened. Leaving the race for pure speed behind, DEEPRobotics takes its wheel-leg design into a far harsher world. At 35 kilograms, the machine is compact enough to weave through damaged underground tunnels, yet strong enough to carry 15 kilograms of gas detectors and thermal cameras for as far as 12 kilometers. Now imagine conventional cameras can no longer see anything at all. The M20's two 96-beam LiDAR units continuously sweep the darkness, silently reconstructing the environment in 3 dimensions. It builds its own map and navigates around deep pits without waiting for a human operator to steer every move. With the M20S, this platform is given even more muscle. Payload capacity jumps to 35 kilograms, while the robot can calmly climb over obstacles as high as 1 meter. A dual battery system allows hot swapping in the middle of a mission. Its sealed IP67 rated armor enables it to withstand water immersion and keep operating in temperatures ranging from -30 to 55 degrees Celsius. The M20S is no longer an athlete. It is an armored scout. It takes the place of humans and moves directly into the heart of danger. But in heavy industry, survival is only half the challenge. Inside industrial complexes stretching for kilometers, a robot must also know how to perform the same task again and again, day after day. After building machines that can sprint at high speed and charge into dangerous environments, DEEPRobotics is moving quadruped robots into a role that is far less dramatic but far more practical. The X30 was designed for the kinds of shifts humans have to repeat every day: patrolling power substations, inspecting cable tunnels, monitoring factory equipment, and searching for early warning signs before a failure occurs. The machine weighs around 56 kilograms and can remain stable on steep stairways, slippery metal floors, and narrow corridors. Mounted on its back can be thermal cameras, acoustic equipment, and a range of specialized sensors. Step by step, the X30 reads gauges, detects abnormal heat, listens for electrical discharge, and tracks subtle changes that the human eye could easily miss. What truly sets it apart is its endurance. The X30 can return to the same location, inspect the same piece of equipment, and perform missions according to a predefined schedule. When workers have to leave areas that are toxic, dangerously hot, or exposed to high voltage, the robot can keep moving deeper inside. If the X30 is assigned the role of observer, the A2-W arrives to shoulder the heavier burden. This 52-kilogram machine has a low, broad body supported by 4 oversized wheels. On flat ground, it glides forward smoothly, like an autonomous tow vehicle. But the moment it meets a rough slope or a broken stone ledge, its animal instincts seem to awaken. Each leg joint rises, lifting the wheels off the ground, carefully searching for a stable foothold before dragging the entire mass of steel and the cargo on its back forward. The A2-W is a silent mechanical porter. It patiently carries 25 kilograms of supplies, the equivalent of a backpack packed with tools, for as far as 15 kilometers. Remove the load, and its operating range expands to nearly 35 kilometers, enough to accompany engineering teams across vast industrial complexes or push deep into mist-covered mountain terrain where conventional trucks would be forced to turn back. Across these difficult landscapes, front and rear LiDAR units act as a pair of watchful eyes, keeping the machine on course. More importantly, its dual-battery hot-swapping system nearly eliminates the concept of downtime. One depleted battery can be removed while the other continues powering the robot, keeping the transport mission moving without interruption. Able to climb slopes of around 45 degrees, clear steps roughly 30 centimeters high, and operate behind an IP56 rated shell that protects against dust and water, the A2-W is, in every sense, a mechanical mule. A2-W still carries the profile of a logistics robot. The Shumaker Sabina Surishawar, however, has crossed into the territory of a true transport vehicle. The machine weighs around 185 kilograms, stretches more than 1 meter in length, and stands nearly as high as an adult's waist. 4 225mm wheels support a thick, low-slung body housing a battery pack of more than 2 kilowatt-hours, along with powerful joints capable of hauling the entire machine across rocky ground, grasslands, and badly broken roads. That strength becomes obvious the moment cargo is loaded onto its back. The B2W can carry more than 40 kilograms, while moving nearly twice the standard payload capacity of the A2-W. With that load, it can still travel around 25 kilometers. Unloaded, its range increases to nearly 30 kilometers. While standing still, the frame can support as much as 120 kilograms, roughly the combined weight of 2 adults pressing down on a metal skeleton. The B2W is not confined to flat surfaces either. Its leg joints continuously raise and lower each wheel, keeping the cargo platform balanced as the robot climbs stairs, clears steps up to 40 centimeters high, or crawls across slopes steeper than 45 degrees. In a specialized configuration, its top speed reaches 15 kilometers per hour, fast enough to keep pace with moving vehicles across a large industrial complex. An Ortogip 67 rated enclosure protects critical components from dust and water, while an operating temperature range from -20 to 55 degrees Celsius allows the machine to continue working through freezing winters or intense heat. This is a platform designed for missions where carts are too weak, conventional vehicles are too bulky, and humans should no longer be expected to carry heavy loads by sheer physical strength. The Mashodi Balnarawan feels like a truck with its cabin removed, its body shrunk down, and 4 highly flexible legs added underneath. It closes out this lineup of Chinese robots with a raw carrying power, and raises the biggest question of all: when one country already has robots that can run, scout, patrol, and transport heavy loads, just how secure is America's long-standing technological advantage? The bigger picture is now clear. China is building a battlefield designed to surround the competition from every direction. Unlike the United States, which has often placed its bets on all-purpose icons such as Boston Dynamics Spot or Leary Vision 60 Henry, Beijing is disrupting the board through specialization. The pressure does not come from some unknown Chinese robot suddenly defeating Spot outright. It arrives when the market can pick individual machines and assemble them into a perfectly matched team. Need speed, choose an ultra-compact platform, need to push through mud and rain, select a fully sealed machine, need heavy lifting, deploy a much larger transport-class robot. Washington reacted almost immediately. Late last July, a new layer of controls was introduced to restrict the next generation of Chinese robots from entering the United States on security grounds. That move confirms one thing: these mechanical packs have decisively left the technology circus behind and are now becoming instruments of geopolitical power. America can still claim the legacy of being the pioneer, but China is applying pressure through sheer diversity. The race is no longer about celebrating a single extraordinary machine. It now belongs to whoever can embed an entire robotic ecosystem into the real world first. From steep mountain slopes to fractured logistics routes, China's growing fleet of quadruped robots is rapidly moving beyond the boundaries of technology demonstrations. They are appearing wherever human limits are tested most severely: silent underground tunnels, sweltering power substations, and rescue sites choked with dust and debris. The United States may still possess some of the world's pioneering robotic technologies, but China is accelerating through sheer diversity. Victory will no longer be decided by laboratory specifications alone. It will be determined in the field, where machines must prove their value through endurance, reliability, and real-world performance. So who will lead this new era? America with its long-standing technological advantage, or China with its rapidly expanding and highly flexible robotics ecosystem? Share your thoughts in the comments, hit the like down button, and subscribe to the Mandarin Tech as we continue exploring the machines that are gradually reshaping our world.